Okay, so we have done equations where quantities are added to the variable, and we move them by adding their opposite to both sides. We have done equations where quantities are multiplied times the variable, and we move them by multiplying both sides by the reciprocal. Now, what do you do when you have quantities that are both added to and also multiplied times the variable? You got to know which one to move first. Common sense would tell you to move the thing, which one first, added or multiplied? Most people say multiply because of the order of operations. This isn't an order of operations issue. And you want to move things added first. You need to know that. This is very, 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 very important. Okay? Move things added first. Move things added first. Move things added first. Very important. Okay? So when you have quantities both added to and multiplied times the variable, move things added first. That'll be 99% of the time. All right? So let's go ahead and go through and take a look at some situations. So if you look at the first equation, the negative 3 is added to the variable, right? It's on the same side as the x. And the 7 is multiplied times the variable. We have to move two things. We got to move the 7 multiplied times the variable, and we've got to move the negative 3 added to the variable. We want to move the negative 3 first. How do you move a negative 3? By adding its opposite, positive 3, to both sides. So like we've done, I'm going to come below. I'm going to add a positive 3 to the left-hand side of the equal sign and a positive 3 to the right-hand side of the equal sign. What do we have left? The 7, I'm going to do it in green, and then the blue x, right? That's the left-hand side. 7x. What is the right? 18 plus 3 is a 21. Now we want to move the 7. The 7 is multiplied times the variable. Therefore, we're going to move it by multiplying both sides by the reciprocal. Or we could do the shortcut, right? So we're either going to multiply both sides by 1 over 7, or we'll do the shortcut, divide both sides by 7, right? We can do the shortcut. Hey, we've isolated the variable on the left. We all know that 21 divided by 7 is 3, and our answer is x equals 3. When you take a quiz or test and you're done, you can go back and check that answer. Put the 3, don't do this in your notes, back in for the x. 7 times 3 is 21. 21 minus 3 is 18. Is the other side 18? Ah, the 3 is a solution, right? You can always check your answers. Again, you would do this after you finished every question on a quiz, after you finished every question on test. What happens if you do it ahead of time before you're done? What can happen to you? You could run out of time. You always do everything first before you go back and start checking. And with math tests, in reality, time is an issue. Okay, second one. So again, you have things that are added to the variable, and you have things multiplied times the variable. So somebody tell me, raise your hand, tell me what you want to move first. Allison, what do you want to move? The 4. And how do you want to move it? What do you want to do to move it? Okay, so I'm going to add negative 4 to both sides. I agree. We'll add its opposite to both sides. I'm going to add a negative 4 to the left. I'm going to add a negative 4 to the right. Now I'm going to keep my color. I still have that n over a 5. Somebody raise your hand, tell me what the right-hand side becomes. Edward? Right. So Edward said 2 negatives and 4 more negatives, 6 negatives, right? We're adding. Okay. Somebody raise your hand and tell me now what you want to move. What do you want to move? Hannah? I'm not sure what you mean by the 5. Okay, if you wanted to move a 5, what would you then do to both sides? And that's not correct. Because we're really not moving a 5. Christina? Nope, the negative 6 is already on the other side from the variable. That's already isolated from the variable. No need to move it. We only need to move things on the same side. Emily? What am I moving? Just answer that question first, and then I'll tell you how to move it. What am I trying to move? Not really. Okay, Brendan, what am I trying to move? Trying to move the 1/5. Again, guys, we don't usually write ones in front of variables, but it is a 1/5 that we're trying to move. And hopefully, as we keep doing these over and over again, it'll start sinking in. Okay, a bottom with a 5 is not a 5, it's a 1/5. So how do you move it? Multiply both sides by 5 over 1. So I'm going to take my green. On the left-hand side, I'm going to do 5 over 1. I'm going to do a raised dot. On the right-hand side, I'm going to do 5 over 1. Now again, for most of you, the 1s are gone, the 5s are gone, n is all by itself. If you need to and you want to put a 1 under the negative 6 to keep track of the fraction, go ahead and do so. What does the right become? Somebody raise your hand and tell me what the right is. Nia? Positive or negative? Yeah, and be careful, Nia, because that'll kill you if you don't say negative 30, right? Negative times a positive is a negative, n equals negative 30. Again, if you have time, you can go back and plug that in and check it out. I'm a little limited with time being we did our quiz today. So let's keep rolling along. Again, you're looking for the side that the variable is on, and you're trying to see if things are both added to and multiplied times a variable. Somebody raise your hand and tell me what you want to move. What do you want to move? Hayden? I agree. And how will you move it, Hayden? I agree. The 7 is added to the variable, so I'm going to add a negative 7 to the left and a negative 7 to the right. Somebody tell me what the next line becomes. Chloe? Negative 4y equals, what did you say, negative 13? Okay. Can I tell you what some students leave off? Instead of saying negative 4y, they just say 4y, but it's a negative 4y, isn't it? Right? I mean, you see the negative in front. And remember, I told you guys from day one, keep the signs with the coefficient. That's a negative 4y. Now, that's important. Now, what do we want to move? Hannah, what do you want to move now? Yeah, see, it's in the top. In the top, it's a negative 4. If it's in the bottom, it's a 1 over that number. So we want to move the negative 4. Somebody raise your hand and tell me how to move it. Juliana? Yeah, divide both sides by what? If you multiply by the reciprocal. If you divide, you just divide by what it is, right? Again, shortcut. Be careful with the shortcut. But we can just divide both sides by negative 4. On the left, our y is now isolated. And you know what? Can we divide 4 into 13? So we're going to leave it as an improper fraction. Don't change it to a mixed number. Leave it as an improper fraction. However, what's a negative divided by a negative? So I'm going to leave the answer as a positive 13 over 4. Because a negative over a negative is a positive. Don't change it to a mixed number. Don't tell me 2 and 1/4. Mixed numbers are for elementary. We really don't do mixed numbers once you get out of elementary school. Every once in a while if it's a certain application. But other than that, we don't use mixed numbers. So 13/4. Leave it as an improper fraction. Edward, question? Okay, just making sure. All right, let's go on to the next one. Okay, now I don't have all that stuff on the side. That's the stuff you should be thinking, though. So again, you look at D and you say to yourself, self. I have things added to the variable, and I have things multiplied times the variable. I better move things added first. So somebody tell me what to do to get started on D. Kristen, tell me what to do to tell me what you want me to do. So what do you want me to do? From where? Just like that? Okay. Improper procedure, right? So I really want to add -10 to both sides. I'm going to start on the side I'm trying to move it from, and I'm going to add -10 to both sides. Kristen's probably doing another shortcut, which is okay as long as you're careful, but we're not doing that shortcut yet. You guys are showing the work for adding a -10 to both sides. She's correct, right? We had to move the thing added first. I end up with a -2 on the left. The 10 and the -10 are 0. Don't lose your negative sign. I have a -2n/3 on the right. Does everybody agree with that so far? Does that make sense to you? Okay, now the key next step. So what do I do next? So again, you're going to tell me what to do to both sides next. What's next? What's next? Looking for Ashley. You haven't given me anything yet. What do you think, Ashley? Okay, so Ashley says this. How many of you would have said 3 over -2? See, a lot of people wouldn't have included the negative, but Ashley's correct. We need this -2 and that -2 to divide out. And you definitely want 3 over -2. And again, let me do it to the other side here before I finish up. Again, I'm going to put this -2 over 1 to make it clear. So on the right, not only did the -2's divide out, but the 3's divide out. And look, our n is all by itself, and it's positive the way it's supposed to be. What does the right end up being? Somebody tell me what the right ends up, Christina? Which equals a what? Not a -3. Amber? Right? The -2 divided by -2 is a 1, and you're left with 3. Right? Negative divided by a negative is a positive. And D is done. Let's do E. All right, somebody raise your hand. Tell me what to do first. Luke? Tell me what to do to both sides. Okay, like this. Okay, you want to do that first? Okay, we can. I agree. All right, and what do you get on the left, Luke? I agree with that. Now, what do you want to do, Luke? Okay, like this, right? Just hold off, everybody, for a second. So just hold off a second. Just stop. So, Luke, what would your left be? Okay, and what would your right be? Okay, so watch. I want to show you a couple things here. Luke, what happens when you add a 9 and a 9? That's 18. And you still have this negative sign, and you still have x. What does that tell you? Does that tell you anything? This is real life. This is what will happen. Yeah, it really tells you made a mistake. Because remember, you were trying to move the 9. Now you turned it into an 18. So something's not right. So can you figure out what went astray? Somebody, it's supposed to be a -9 exactly. And Luke, if you can catch that yourself, then you'll catch your own mistakes, right? Remember, that's always supposed to add up to 9. That's why Kristen's shortcut is very dangerous. Her shortcut is to just stick a -9 on the other side. But if it would have been Luke and just stuck a 9 on the other side, he'd never catch it on the right side. He'd never catch that he made a mistake. He'll never know it. It's very dangerous. Do it later when you're really good at stuff. All right, so we have a negative 20 on the left, and be careful. You have a negative x on the right, do you not?
Yes.
You still got that negative there in front of that x. It's a negative x. Hey, we can do the shortcut here. Somebody tell me how to finish this off with the shortcut. We learned this yesterday. Remember the shortcut yesterday when your variable is negative? Julia? I don't know if I'd say you swap the negative. I'm not sure if you want to quite say it that way, Colby. If I change it from a negative x to a positive x, what do I do to the other side?
Oh, you would change
Okay, so remember, hey, Julia, everybody, if you change the sign on the right side, change the sign on the other side, whatever it is. So this goes from negative to positive. I got to change this. So the other one is negative, so now I got to change it to its other, and it goes to positive. So x equals 20, and that's the solution to that. Okay, F. Somebody raise your hand and tell me how to do F. Amber, go ahead. I agree. I'm going to add positive 5 to both sides. Somebody tell me, let's see, Omar, you've been quiet back there. Omar, what's the next line going to be? He says negative 6n equals 24. How many agree? And that's correct, right? And he kept that negative sign, which is good. Somebody tell me what to do next. Hannah? Correct. We can do the shortcut right here. We'll divide both sides by negative 6. See, equations are easy. And eventually all equations end up down at this place. All right, our negative 6's divide out, isolating our variable. Positive divided by a negative is a, don't miss the negative. And 6 goes into 24 4 times, n equals negative 4. Okay? Hey, don't miss your signs. Think. So, when quantities are both added to and multiplied times the variable, move things added first. Move things added first. Really important. There is one special case. Okay, and I didn't write it there, but this is called the special case. And you'll hear me refer to the special case. In Algebra 1, a couple days ago, I said, this is the special case. This one's unique. Notice the blue box. You have a fraction, and the top of the fraction has the variable and something else added to it. But it's the top of a fraction. You can't move that negative 2 right now. You can't. The negative 2 is tied into the n and tied into the 3. Because do you remember a fraction bar is also a grouping symbol? It is. That's grouped as one fraction. And if you try to move that negative 2 right now, you can't move it. Now, I know you guys don't understand this, but this is the exact same problem. 1/3 times the quantity n minus 2 over negative 3. It's exactly the same thing. If you don't think so, here I'll show you. Don't do this in your notes. If I had a 1 on the bottom, two fractions, right? What's a 1 times an n minus 2? An n minus 2, right? What's a 3 times a 1? A 3. See how we're right back to it? Again, I know that's hard for you guys to visualize, but it is the case, and it is what it is. So if you had a 1/3 times an n minus 2, what we want to do on the special case is we have to look at this as a 1/3 times an n minus 2. So that you can write in your notes. Put a parentheses around that n minus 2 and put a 1 in front. I'm really going to move the 1/3 first. This is an exception. It doesn't happen often. About 1% of the time, about 1 out of every 100 problems, this exception comes up. Any idea how I'd move the 1/3? Now remember, math is orderly. You could ask yourself this question. Technically, is the 1/3 added to the variable or multiplied times the variable? Definitely not added. It is multiplied. Isn't that clearly multiplied times the variable? How would you move it then? You'd multiply by the reciprocal, which is? So I'm going to multiply the left by 3/1. And whatever you do to one side, you got to do the same thing to the other side. Again, this is an exception. Don't be looking for this all the time. It only happens in this situation where the numerator is a fraction with the variable and there's things added to the variable. Okay, before I go any farther, just want to stop for a second. Do you see the difference between that and this? Do you see the difference? Look at just the fraction part. The numerator is just the variable and something multiplied times it. Where in the special case, see the difference in the numerator? See how it looks different? That's what you got to spot, okay? Because back up here on D, we do it the normal way. Move the thing, add it first, then move the thing, multiply. But down here on the special case, we've got to move that 3 first. Okay, so look where we end up. 3 divided by 3 is 1. They go away. You're left with the n minus 2 equaling, and hopefully you agree, negative 3 times 3 is a negative 9. Now I have a simple problem. Now I want to move the negative 2. Somebody raise your hand and tell me how to move the negative 2. Allison? I'm just going to add a positive 2 to both sides. Exactly. I'm left with n. I don't really need that parentheses anymore. 9 negatives and 2 positives leaves me 7 negatives, right? Negative 7. And that's the answer. And again, when you have time, you can go back and check it out. 7 minus 2 is 5. A negative 7 and a negative 2, I'm sorry, is a negative 9. Negative 9 divided by 3 is a negative 3, and it works. Oh, there's the bell. I won't get to that last special case, but there's your homework. Remember, the special case is special. How many will you get of that? Only a few, and probably toward the end of the assignment. All right, have a great day.